Welcome back, science enthusiasts. Today, we have an exciting topic to dive into. We'll be exploring the wonders of the largest and most powerful particle accelerator ever built, the Large Hadron Collider, also known as the LHC. Get ready for an incredible journey into the world of particle physics. I'm your host Krishna, and let's begin. The Large Hadron Collider, located near Geneva, Switzerland, is a colossal scientific experiment. It stretches underground in a circular tunnel with a circumference of 27 kilometers. Its purpose is to unlock the secrets of the universe by recreating conditions similar to those just moments after the Big Bang. So, let's break down how this remarkable machine operates. The LHC consists of a series of superconducting magnets that accelerate two beams of particles, usually protons, in opposite directions. These beams are guided by magnetic fields, creating a controlled and precisely focused path. As the beams reach close to the speed of light, they are made to collide head-on at specific points within the LHC. When these high-energy particle beams collide, they release an enormous amount of energy, recreating conditions similar to those moments after the Big Bang. This energy allows scientists to study the fundamental building blocks of matter and explore the mysterious realms of particle physics. But what happens during these collisions? Well, the energy released during the collision can convert into new particles, which only exist for an incredibly short time. These fleeting particles include the famous Higgs boson, the particle responsible for giving other particles their mass. To detect and analyze these particles, the LHC is equipped with gigantic detectors positioned around the collision points. These detectors record and measure the properties of the newly created particles. The data collected is then carefully analyzed by scientists from all over the world. The discoveries made at the LHC have revolutionized our understanding of the universe. In 2012, the ATLAS and CMS experiments at the LHC announced the discovery of the long-sought Higgs boson, confirming the existence of the particle predicted by the Standard Model of particle physics. This groundbreaking discovery has opened up new avenues of research and has provided valuable insights into the fundamental nature of matter and the origins of the universe itself. But the LHC's journey doesn't end there. Scientists are continuously pushing the boundaries of knowledge at the LHC. They are investigating the mysteries of dark matter, antimatter, and other unexplained phenomena. The LHC is truly a beacon of scientific progress, bringing together experts from different fields to collaborate and explore the unknown. However, the road to these groundbreaking discoveries is not without its challenges. The immense scale of the LHC requires advanced engineering and technology, as well as a massive international collaboration. It's a testament to the determination and dedication of the scientific community. So, the next time you hear about the Large Hadron Collider, remember that it's not just a massive underground ring. It's a symbol of human curiosity, ingenuity, and our unrelenting quest for knowledge. And that concludes our journey into the fascinating world of the Large Hadron Collider. I hope you enjoyed this video and learned something new. Stay curious, keep exploring, and I'll see you next time. Thank you for watching. Don't forget to like, share and subscribe.